Moving on to the main topic for today, geoprocessing. The first slide shows a good definition of geoprocessing. The processing of geographic information, which is actually a bad definition because it uses the words itself in the definition. What it does is it creates new information by applying an operation or operations to existing data. And that existing data might be a single feature class or shapefile, or it might be multiple shapefiles. Any alteration or information that you want to perform would require something that would be defined as a geoprocessing task. Geoprocessing tasks may be simple, converting from one format to another, or they may be very complicated, involving clipping, selecting, buffering, intersecting of data sets. In my experience, I found that literally any combination of layers and spatial operation across data sets, there is a tool for. There is a way to complete that procedure. Any question essentially that could be asked of the data is answerable using ArcGIS through some series of geoprocessing commands. So how does geoprocessing work? Geoprocessing is oriented toward what are called tools, which are run via dialog box. And in order to do a geoprocessing task, one needs to find the tool, open its dialog box, select what are called parameters, the input values for that operation, and then click OK. And we do find all of the tools in the Arc toolbox, a handy place for them to be, such as is demonstrated here. And the analysis tools. Analysis tools is a synonym for geoprocessing tools, are quite substantial. Spatial join, intersect, clip, select, buffering, near, distancing. There are probably at least 100 different operations that allow us to extract meaning from data. An example, the simplest one, the one that every teacher always shows first, is something called a buffer. There may be a circumstance that needs analysis in which some effect is felt within an area and up to a certain distance away from that area. And buffering allows one to create a new area, a new feature that includes the original area plus some distance outside of it. And usually one wants to do dissolve, which will remove the lines that would have formed, because this buffer actually buffers each of these separate features in turn, and that you can end up with internal lines cutting through. But if you dissolve, you can get rid of all the internal buffers and make continuous polygons. It's possible as well in a single operation to create multiple buffers around one or all of the features in a data set, and the distances of each buffer can be defined in various ways from a file by typing them in, etc. So multiple ring buffer analysis is a possibility. Clipping is a very common form of geoprocessing, and it can be really thought of as a cookie cutter. Just like making holiday cookies, here we have the dough rolled out, and that's the source data or the input data. The cookie cutter or the clip feature is another data set, and the result is this clip feature applied to this source data, and that's what's left. And it includes all of the features from the input data set, and they're reduced in size. Clipping is very reduced in extent. Clipping is a very common operation. One can clip not only polygons, but you can clip line features and input and point features as well by using a clip. It doesn't have to be a polygon feature that gets clipped. And one can use line or point features as the clipper as well. The results of operations like that become a little bit harder to understand, but they are possibly useful in some circumstances, and they're perfectly legal in ArcGIS. One has to be somewhat careful when doing clips, because in some cases, or in many cases, attributes for particular features are unchanged. So the attributes will travel along with each fragment that's left over when something is clipped. If it's in some cases, that's fine, but in the case perhaps where a polygon feature is clipped by another polygon feature, and one of the attributes was area, the actual area of the resulting clipped polygon will be smaller in reality because a piece got chopped out of it. However, the attribute that happens to have the title area won't be changed. It just travels along automatically. The newest versions of ArcMap do generally recalculate areas when clip operations are done automatically, but that's still something that needs to be watched out for, is what happens to the attributes. There's other analyses possible in the geoprocessing toolbox, such as split. In this case, it's possible to have multiple cookie cutters all at once that creates multiple, it's kind of an industrial scale cookie making in this case. Another geoprocessing tool is called PointDistance, which computes the distance from each particular feature in the input feature class and determines what's the closest feature in some other feature class. Here we have feature class of red squares, and here we have feature class of black circles, and it will, and this is obviously an exceptionally simple case, but it will, this tool will calculate the distance from each feature in one data set to the closest feature in another data set. This is similar, again, another very similar program is called near, and I will give a demonstration of that, and you will take a crack at using the near function as an exercise. The near function does the same thing I just described. It finds the nearest point in one feature class to every feature in some other feature class, and it can be very useful. I'll show you how that works in the demonstration. Maybe that'll become a little bit clearer. There's an opposite of a clip, and that's an erase. And in this case, what we're left over, or what we have as an output in this case, is not the cookie after doing the cookie cutter, but the dough that's left over after the cookie has been taken away. So most any operation, spatial operation that can be imagined, can be done in one way or another. Saw this in the news, and as I say, I have no comment on that. I'll next move on to the demonstration video.